Lesson terraforming, specifically photochemical dissociation from Mars. Playing off what we were talking about yesterday about remix, repeat, remain, and that being already done, but we didn't remain or repeat it, is also true for this. So those who have been studying it and have been on this journey for a while will know which one we're talking about, which leaf pill has already been played and we're replaying it and remaining remixes. There's going to be a little bit of a alteration to it, which is fine. There's actually a challenge in there. There's actually a challenge in there for you all. We'll get into it though. So basically, photochemical dissociation for Mars given attributes, and we're focusing on the atmosphere right now. And the atmosphere of Mars is 95% CO2, so it's just CO2. Okay, so photochemical dissociation, basically you have a molecule, CO2, and through their bond, which is electrostatic, there is a dissociation of the molecule. Usually it's an energy base, sometimes it's radiation. I use both. Which one's more natural, which one's not, it doesn't really matter as long as you can accomplish it. We found using this, we can use the light of angstroms with the Hertz intention, energy, matter, mass, to and fro, to accomplish photochemical dissociation, which is great news, because if we have a carbon and an oxygen, CO2, and that's what makes up 95% of Earth's, Mars atmosphere, and we use photochemical dissociation, we can essentially, and exactly what we're doing, we can separate the bond of carbon and oxygen and disassociate them from one another. In doing so, we would just have a carbon and an oxygen separate, which is incredible because now we don't have CO2 in the atmosphere, which just isn't hospitable, and you will die if you breathe it. So the next challenge becomes, and yeah, the process to do it is the same deal. Hertz, speculative formula, deployment, etc. So all of that's still true. There's a formula for it, for what amount you would need. Right now, I'm not super focused on it because you can, the great thing about this overall formula of converting your words energy into matter, mass, to and fro, is that you can say it what you need and then it fits in to your need. There's a formula that will back how it happened, but right now I'm not super focused on doing it because you get the same results either way. So we'll come back to that, but just know you all could probably figure it out yourself, but well, we could go into it much down the road. Okay, so if we're using angstroms to disassociate the electrostatic association, and Hertz is our intention, the distributed, etc., then what does each one do? Well, if we take the CO2 and we photochemical disassociate an amount that gives Mars atmosphere the amount needed, where would the C go? The C, which is carbon, we remagnetize and we reassociate because it's a magnetism and an association that once it's disassociated sets this one here, carbon here, and it sets oxygen there. Boom. So there's another process following the initial disassociation. For carbon, we're going to be using it with hydrogen, right? Specifically four hydrogens, as you know, with carbon, CH4 is methane. Methane is a heater. It is a heater. Mars is cold. And we're going to also keep Mars naturally cold with the oceans warmer. This is a tangent we'll get into later because we think it's a good phenomena to know that it is occurring. So it's going to be naturally a colder planet, but the oceans are going to be warm. It's awesome, but we'll get to that later as well. So we're going to disassociate the carbon and reassociate it with hydrogen, where the hydrogen comes from a few minutes from now. Okay, and so it's going to be instantly high amounts of CH4 in the atmosphere while it's heating up the surfaces of the terrain of Mars before it levels out with a naturally Mars low temperature. So you'll see high amounts of CH4 before it levels out. You won't see much at all. Okay, and then the remaining carbon are going to be objects as reservoir. This naturally occurs in Earth, etc. So it's going to be in places like oceans. It's going to be in places like plants. It's going to be places like rocks and things like that. More into that later. So our oxygen that is photochemical disassociated is obviously going to be the atmosphere. Now, as humans, we have about 78% nitrogen, 21% oxygen, and 1% argon, excuse me. And that number fluctuates. So some say, well, it's 0.9 and that one is 20.1. That's okay. We're just going to go on this one right here. All right, because believe it or not, you breathe different amounts of oxygen all the time. Like, for example, you could go to your local truck stop. I know in places like New Mexico, Colorado, Utah, higher elevations, and you can get a canister of oxygen just so that you can breathe better, because the oxygen is different at a higher elevation than lower. So it fluctuates, and it's a natural process. Huge fluctuations, 20%, 10%, even 5% is a big deal. But you start going with 0.1%, 0.2%, we're naturalized. It's actually gravity that really hurts our body. Much more on that later. So the oxygen is going to go to the O2 atmosphere. So then you're going to look into different problems. You're going to see, well, where does nitrogen? Mars doesn't have nitrogen, and only trace amounts of it. You need 78%. Those who have been studying this, what did we use? And that's a pop quiz. You can fill it out and make sure your responses are insured for people not sure where the nitrogen came from. And it is a thanks to Ganymede, just to spoil your fun. So that's where our nitrogen is going to come from. Our argon, believe it or not, there's already enough argon trace amounts that we don't have to worry about it. And a big point of this was just to explain it with lights, camera, action. And a big part of it was to get you all talking about it and making sure you're insuring it. All right, so with our picture, we know this disassociation, we have this, and our O2 is our Hertz atmosphere, and our dimensions is length, width, height of what the magnetosphere gives. Okay, so that's pretty simple, right? So that's not, I'm trying to simplify it as much as possible, just so that it's digestible for everybody. So there's a molecule right here. You come in with light, you strike the electrostatic bonds, they separate, and then you strike it again once they're separated and send them to a new place. That's photochemical disassociation. And completely in a nutshell, that's easily done and digestible. Good. So our next place we're going to focus on is this right here is a stairway. That's a pineal stairway, buddy. So if we have Mars down here and it's unhospitable and it's like 1.52 AUs and it's too much, right? So this is a stair of how to get it to hospitability. But what stops the solar DH ionic order for CO2 atmospheres, right? Well, one is going to be the R magnetosphere. Then we get our photochemical disassociation, which we're going to lead next with atmosphere. Then we're going to take the stair to oceans. Then we're going to take the stair to moons. Then we're going to take this stair to planets, Then we're going to be hospitable, which is good. So that's just going to be the process of it. Okay, now going further on the dissociation, once oxygen came down, we know it's going to go into here at 21%. So then where does the water come from? From the disassociated. Good. So where does the hydrogen come from? Those who have been studying it, you're going to know where we did it from. But one thing we're also going to do too is we're going to be taking the actual solar CP, the actual solar charged particles, because as we went into, solar gives us hydrogen and helium new. So we're going to we don't have to completely disassociate other moons, etc., to get hydrogen or helium. We will do it, but we need to also use what's given to us, because it stops the DH ionic order and lets the solar know where we are and what we are capable of, that we're a functional living organism with a controlled aspect of how it works. So that's a main reason to be using solar CP before we use other solar system masses. That's not always true, right? Because it's like nitrogen, we use Ganymede. We use Jupiter's moon Ganymede for the nitrogen. Nitrogen wouldn't come from the sun. So there's going to be other places. The moons, when we re-put in moons, that's going to change things as well. We have to use other places, other masses for it. Okay. And this is the process right here for how we stop the solar DH ionic order. They're stopping the DH ionic order, and then there's making TiH greater than, because TiH is greater than DH, which implies that it's a process 2B. So in a real orthodox way, we would say TiH greater than or equal to DH, but that can be pessimistic because it implies that DH has an opportunity to be equal. So the best way to say it is TiH greater than DH, with the implications of the orthodox is also true with its pessimism. Okay, so a little bit of philosophy there. Now, there was... Oh, okay. Now, when you were studying the remix that we did, and this was, man, I was still in graduate school. No, it's not graduate school, but I was still in college. And we did the remix, and it was surprisingly similar because it was surprisingly near the time of remixing what we were doing yesterday with the core convections in the magnetosphere, which means when we did it from Earth as a remix. So the same price tag came on that we did it from Earth, and we need to remix it to that 88,775 of Mars solar day. Okay. Now, I was speaking earlier that there's going to be a challenge. Okay. So a lot of people are saying, well, if you go 6 days at 88,775 and you leave one day at 86,400, what's that going to do? Will it be harmful? It's not harmful. We took precautions to make sure it's not harmful. To better understand how time routines gravity, we are choosing to allow it to be better studied and better understood rather than just massively applied instantly. So as you know, with yesterday's, or whenever you're reading it, the core convections, we left one day as still 86,400. On this one, we're not going to do that. We're going to remix, repeat, and remain all of them at 88,775. So that is going to give people who are studying it incredible anchors for understanding. So that's your challenge, to figure out, and it's always going to be Kepler's square, just to let you know. It's always going to be Kepler's square. Okay, so on our remix, if we were to plug this into the formula, it would look just like yesterday's of where it's happening, but our hertz would have this photochemical dissociation that C is going to CH4 for X amount of time, and then the reservoirs of it are going as reservoirs. And then our oxygen is going onto this atmosphere with nitrogen that we, Ganymede, goes there, and argon's already traced, and any leftover oxygen from that amount is going to be in water, and our water's H and our methane's hydrogen is coming from first solar charged particles and second solar system masses, which is more relative during moons, but it does happen. Okay, so the next thing that would change is still going to be LDD 1 through 2, 16 through 29. All of that's still going to be the same. Still 90 degrees for infinite expanding universe, advantageously. The difference is where we were doing time of 88,775 times 6, it's 88,775 times 7. Okay, and then the rest of it will take, yeah, the rest of it's the same. Good. Looks right. Yeah, it is. It's correct. It is correct. So, in closing, we'll be hearing a V Ainrod, and that will play it for 7 days. Then, once this is done, we're going to start working on oceans. Oceans are technically built from the atmosphere. This is a cool concept. This is a cool concept that physicists and geologists are going to become buddies, because physicists talking about, remember whenever we said about there being one place and everybody would gravitate to that place, but it was missed not because it's unknown or not possible, but because we didn't know we could convert energy into matter in regards to like the death ionic order, dying force, etc. Okay. Atmosphere create oceans. And atmospheres create oceans because once you start changing what the atmosphere is, these trace elements that are in the atmosphere drop down onto the ground naturally. Photochemical dissociation is a natural process. We just found a way to speed it up instantly, you know? So it's a good thing. But you're going to find when you're studying it, and you're taking on that C14 conundrum, you're going to find that this is how it was done, is that atmospheres make oceans. And moons, furthermore, moons determine what plants you have as well. We'll get into that later. All right, so with that, there is a lot of work for you all to do. And I will see, let's figure out what the V Ainrod is on this. It's the same as yesterday's, but instead of core magnetosphere, it's just atmosphere.